Welcome, my dear friends, to my new YouTube channel. Today, we will discuss the use of IC555 as a monostable multivibrator. As you can see, the three resistors of 5 kilo ohm each are connected between VCC and ground. So, the voltage across each resistor is VCC by 3. The external resistance Ra is connected between pin number 8 and pin number 6. Pin number 6 and pin number 7 are connected together. The capacitor C is connected between pin number 7 and ground. Pin number 4 is connected with VCC, and the output voltage is obtained at pin number 3. We can apply the trigger at pin number 2. The trigger can be applied at pin number 2. So whenever pin number 2 is connected to the ground, the voltage at inverting terminal of comparator 2 becomes 0, and the voltage at non-inverting terminal of comparator 2 is VCC by 3, as the voltage across this resistance is VCC by 3. Due to this, the comparator 2 output becomes high and it sets the flip-flop. As the RS flip-flop is set, the output Q becomes high and Q bar becomes 0. As Q bar becomes 0, due to this inverter, the output of IC555 becomes high. Further, as Q bar is 0, this transistor becomes off. Due to this, the capacitor C starts to charge through Ra with a time constant Ra into C. So the capacitor charges exponentially with time constant Ra into C. As soon as the voltage across the capacitor just crosses to VCC by 3, at that time the voltage at non-inverting terminal of comparator 1 becomes higher than the voltage at inverting terminal of comparator 1. Due to that, the output of comparator 1 becomes high. This resets the flip-flop, and correspondingly the output Q becomes 0 and Q bar becomes high. As Q bar becomes high, correspondingly the output of IC555 becomes 0. Further, as Q bar is high, the transistor becomes on. As the transistor becomes on, the capacitor, which was charged up to 2 VCC by 3, will start to discharge through the transistor. So the voltage across the capacitor decreases exponentially. This way, the output of IC555 remains high for the time period which is decided by the charging time of the capacitor through resistance Ra. Now let us calculate the time period for which the output of the monostable multivibrator remains high. This time period is decided by the charging time of the capacitor through the resistance Ra. The exponential charging of the capacitor is represented by the equation Vc, the voltage across capacitor, is equal to Vcc into 1 minus e raised to minus t upon Ra into C. At time t equal to capital T, the voltage across capacitor becomes 2 Vcc by 3. So if we put these two values in this equation, we get 2 Vcc by 3 equal to Vcc into 1 minus e raised to minus T upon Ra into C. VCC cancels out on both sides, so we get 2 by 3 equal to 1 minus e raised to minus T upon Ra into C. If we modify this equation, we can write it as e raised to minus T upon Ra into C equal to 1 minus 2 by 3, which is equal to 1 by 3. If we take inverse on both sides, we can write e raised to T upon Ra into C equal to 3. When we take ln on both sides, we get T upon Ra into C equal to ln 3, which is 1.1. So we can modify this equation and get T equal to 1.1 Ra into C. So this is the time period for which the output of the monostable multivibrator remains high. So it must be clear that whenever we apply a trigger at pin number 2 by connecting it to the ground, the output of monostable multivibrator remains high for the time period T, which is decided by the charging time of the capacitor C through the resistance Ra. Thank you for watching.